Good day, esteemed and honourable guests. My name is Justin Weldon, and I'm the authorised distributor of RoadStabiliZOR. The purpose of this presentation is to introduce RoadStabiliZOR to interested parties in Zambia and to understand at a very high level some of the road infrastructure challenges experienced, as well as their subsequent impact. The solution to these impacts will be illustrated through documented case studies from 2008 to 2013, providing the evidence that our technology is tried and tested with proven efficacy and results. I will explain what chemical stabilisation is, which will give context as to why this method is being adopted globally. Detailing traditional construction disadvantages versus stabiliser advantages and the implementation processes and results thereof will indicate that there is a national, continental and global push to adopting new implementation standards with the support of early adopters and recognised institutions. A growing economy is built on three foundational pillars of national infrastructure: electricity, water and roads. Road infrastructure in particular determines how effectively people and goods move across the country. Yet studies indicate that only 17% of agricultural Zambians live within 2 kilometers of an all-season road, leaving most rural communities without dependable, year-round access. When we look at rural road networks more broadly, only 21% of roads are in good or fair condition, despite agriculture being the backbone of livelihoods and economic activity. This challenge is not unique to Zambia. Across Africa, there are on average 31 kilometers of paved road per 100 square kilometers, compared to 134 kilometers in other developing regions. Climate variability, extreme rainfall, and drought accelerate road deterioration, while maintenance gaps leave networks increasingly vulnerable and expensive to repair. At the same time, globally, road construction is shifting towards more sustainable low-carbon alternatives, as opposed to traditional bitumen and asphalt. The economic impact of poor roads is significant. High transport costs reduce farmers' profits, discourage investment, and increase the price of goods and services by 30 to 40%. Congestion, potholes, and slow travel times limit market access and create chronic inefficiencies. However, the opportunity is equally clear. Improved road infrastructure reduces transport costs, increases delivery speeds, and expands markets. Evidence from regional corridors shows that infrastructure investment can increase regional GDP by more than 20%, while modern road networks can boost Zambia's overall GDP by over 2%, supporting SME growth and job creation. The answer is clear: new reforms, new ways of working, and a faster, more streamlined and cost-effective solution when it comes to roads. Real-world case studies demonstrate the long-term performance of these solutions under different conditions and traffic demands, with RoadStabiliZOR being one of those opportunities. Starting in Lubumbashi in the DRC, these images show roads constructed in 2008 carrying daily urban and industrial traffic. Despite challenging soils and climate conditions, the stabilized road surfaces remained intact with minimal dust, erosion or structural failure over time. The Delstrom case study in Mpumalanga, South Africa is particularly important as it provides a 6-year performance comparison. The road was treated in 2007 and by 2013 the stabilized running surface remained structurally sound and trafficable. What is especially telling is the contrast visible in the images. The stabilized road section remained intact, while the untreated edges and surrounding material had eroded away over time due to water and environmental exposure. This clearly demonstrates that the stabilization process addressed the fundamental interaction between soil and water, rather than simply treating the surface. The images from SAPI's forestry road network in Mpumalanga further reinforce this point. These roads carried heavy timber haulage vehicles under high axle loads, yet the stabilized surfaces have consistently delivered durability, reduced dust, and lower maintenance requirements, even in high rainfall environments. The solution is supported by evidence that builds confidence through fully documented case studies, not concepts or pilot claims. Each project is backed by engineering reports, laboratory testing, and independent assessments, and is available for review and distribution. Together, they confirm that road stabilizer has been tested, measured and proven in real operating environments. So what do we mean by soil stabilization, and how is it achieved? Stabilization is the treatment of soil, carried out through a controlled combination of water, chemistry and compaction. Firstly, water is used as a delivery mechanism, not as a binder. Through controlled moisture regulation, water ensures the stabilization agent is evenly distributed throughout the soil layer. Clay soils are naturally negatively charged and are made up of fine plate-like particles. In this image, we see clay as thin plate-like particles stacked on top of one another, creating an extremely large surface area. This surface area allows water electrostatic forces to dominate, which is why clay becomes unstable, weak and highly sensitive to moisture under traffic loads. These plates are loosely held together by weak opposing negative forces, which makes them sensitive to water and unstable under load. When road stabilizer is introduced, it supplies positively charged ions into this negatively charged environment. This weakens the opposing forces between the clay plates, allowing them to be compacted more closely together. These reactions create a more stable soil structure that is less sensitive to moisture. The result is a soil environment that becomes highly receptive to compaction, enabling very high density and strength to be achieved using the existing in-situ material. So why is stabilization used, and why has it become a tried, tested and proven approach in road construction? The Code of Ethics of the National Society of Professional Engineers promotes that it is an engineer's responsibility to creatively problem-solve sustainable development using local resources while conserving and protecting environmental quality and the natural resource base essential for future development. Soil stabilization allows engineers to work with naturally occurring in-situ materials rather than relying on the costly and disruptive import of external aggregates. This reduces logistics, costs, and dependency on third parties. From a health and safety perspective, fewer truck movements and lower dust emissions result in cleaner air, safer travel, and improved community health. Economically, smoother and more durable roads improves productivity, reduces vehicle wear, and enables reliable delivery of goods and services. Stabilization also strengthens social connectivity. All-weather roads provide consistent access to schools, clinics, police services, and markets, empowering communities and improving quality of life. Finally, stabilization supports environmental protection and agriculture. Properly engineered surfaces reduce erosion and dust, protect soils, and lower carbon emissions, which in turn improves livestock productivity and crop yields. So let's compare traditional road construction methods with a stabilized in-situ approach using road stabilizer. Here, we see a conventional road structure. Traditional construction relies on multiple imported layers, crushed stone, selected fill and aggregates, all placed over weak, highly plastic in-situ clay. This approach comes with several disadvantages. Traditional construction is maintenance heavy, often inconsistent in quality, and highly dependent on water, particularly where cement and lime is used. It requires large volumes of raw materials that are expensive to transport, vulnerable to theft, and labor and equipment intensive. Construction is also climate dependent, often limited to dry seasons, and costs can range from $300,000 to over $1 million per kilometer for asphalt roads. In addition, quarrying and cement production carry a significant environmental cost, with cement alone contributing around 7% of global CO2 emissions. In contrast, using the road stabilizer approach instead of importing aggregates, the existing in-situ clay is chemically stabilized, creating a strong, uniform road layer from materials already on site. This allows compaction levels of approximately 97% mod H2 with up to 40% reduction in water usage and no reliance on quarry aggregates or cement. Implementation time can be reduced by up to 80%, costs by up to 85%, and dust by up to 90%. Over time, the The stabilised road continues to gain strength through traffic-induced compaction, while maintenance costs are reduced by around 70%. Importantly, because there is no cement or imported aggregates, theft risk is effectively eliminated. The result is a road solution that's environmentally responsible, cost-effective, faster to deploy, and better suited to local conditions, delivering durability, safety, and long-term value using local materials. RoadStabiliZOR replaces complexity with simplicity and imported cost with local capability. The implementation process, while technical in nature, can be taught through experience and local engagement. This results in road construction being delivered with communities, not just for them. Here, you can see the physical construction steps, scarifying the existing surface, box cutting where required, and preparing the in-situ material to the correct design, mix, and grade. These are standard familiar construction activities that use locally available equipment and skills. Then we move into dilution, blending, and compaction. RoadStabiliZOR is introduced through controlled moisture regulation, evenly blended into the existing soil and compacted to achieve the required density. This process is straightforward, repeatable, and does not rely on specialized or imported machinery. But the real value extends beyond construction. Community-led road construction strengthens local ownership. When communities are involved, they see the road as their road, which promotes accountability, national esteem, and a self-recognized sense of dignity. This approach also enables training and skills transfer. Local teams are trained in basic construction practices, compaction control, drainage awareness, and routine inspection. This builds local contractor capacity, creates employment, and reduces long-term maintenance costs. In short, this is not just road building, it is capacity building. It delivers infrastructure while developing skills, strengthening communities, and extending the life of the road. The outcome is sustainable infrastructure that communities understand, maintain, and take pride in. So let's bring together two important considerations: real-world performance and formal engineering standards. Observed 6 weeks after construction, you can see the implementation results, following more than 250 millimeters of rainfall. The surface remains intact, trafficable, and stable, and the distinction between treated and untreated areas is easily distinguishable, demonstrating that the stabilized layer is performing as intended under environmental stress. Regarding road specification standards, for many years, organizations such as COTO, together with industry bodies, laboratories, and engineers, have developed formal standards and test frameworks for stabilized road materials, including the TRH-24 Upgrading of Unpaved Roads Technical Recommendations, focusing on nano-modified emulsions, or NMEs, and chemical stabilization technologies. These standards provide engineers and authorities with objective, repeatable criteria to assess performance, durability, and compliance. Importantly, this is not theoretical. Early adopters, including consulting engineers, laboratories, and implementation partners, are already actively involved in testing, validating, and delivering these solutions in real environments. They are committed to sharing this knowledge because the objective extends beyond road construction. It is about community upliftment, achieved through sustainable, reliable, and affordable infrastructure technologies that create long-term value for people and economies. This is how innovation moves from standards to sites to lasting community impact. Innovation is how we shape the future, and thought leadership is what turns big ideas into reality. If you want individuals to think big, give them something big to think about. By embracing pioneering solutions like RoadStabiliZOR, we can uplift communities, empower your citizens, and set a new standard for infrastructure that delivers on jobs, dignity, and growth. Thank you for your time, and thank you for your attention.